we will access the array using a pointer. That is, either we're putting data in the array or retrieving data from the array. So let's suppose we have this program where we've defined the size of an array to be 5, and this array will hold 5 doubles, right, or type float numbers in it. So now we need to declare an array to be able to access it. A pointer to be able to access it. So let's do that. First, you have to understand that you are storing data of type double. So your pointer has to be of type double. Why is that? Because remember when we did an array of type integer, each address occupied 4 bytes as you moved forward. In our case here, since it's going to be a double, it's going to occupy a lot more than 4 bytes. So your pointer needs to know that. It needs to know the resolution with which it's going to move forward within the array. Luckily, you don't have to remember how many bytes a double will hold or how many bytes an integer will hold. You simply make sure that you are consistent in how you declare your pointer. So your pointer has to be of the same data type as the payload for the array. In other words, here's my pointer. And let's call it array PTR. So this would be the pointer for this array. Now, could I just put a semicolon and then initialize it to the array? Yes, or can I do it all at once? You could do this. My array. And that's it, semicolon. Now you're going to say, well, wait a minute. My array is an array. What happens to the brackets? What happens to the % for an address? The name of the array is the starting address of the array. So you've got a point. You've got already a starting point. And remember, when you increment your array in the loop later on to access the data, it will automatically increment by the number of bytes occupied by a typical double. So in our case, this would have been equivalent. So I'm just going to write here an alternate way you would have done this. So double, asterisk, and that would be our PTR. Now you could name your pointer anything you want. And you could have done it this way. My array. But if you're going to use the %, then be very specific. Where do you want to start? That would be element 0. So the address at element 0. So this line here is basically equivalent to what I did on the right-hand side. Okay? So much easier to remember this now, that you only need to worry about the array name. It really is the address or the reference to the first element. Okay, now, can we use some sort of loop to access the array, and within that loop, we're going to use the pointer to populate? Absolutely. And so let's do a for loop. For int I equals 0, I for the index, you can do that, or as a counter. Notice if we're going to use a pointer, we do no longer need the index. Okay, so pay attention. So I is less than size, so we're just going to use it to move a counter, right? So I is simply going to be in a counter, and then I plus plus. And let's go ahead and put a couple curly braces here, because we've got a few lines within that loop. Okay, the first thing you're going to do is you're going to ask your user to enter a number. Now, here's where it gets interesting. Where do you enter the number? Now, remember, your pointer is already pointing at element 0. So dereference the pointer at this stage. Star AAR PTR. Okay, good, but we're not done. You need to move the pointer to the next element. Otherwise, what's going to happen is you're going to be writing over 5 times the same first element since the pointer is statically remaining there. You need to move it. And how do we do that? AARRPTR plus plus, right? So this is equivalent to saying AARPTR equals AARPTR plus 1. We've seen this before. So this allows you to move the pointer to the next element. So by the time you get back inside the loop, you are already pointing to the next element. Okay? Good. Now, can we use the same technique to retrieve the data back from the array? Now remember that your pointer, however, by the time you finish this loop, will be pointing at the end of the array, if not beyond. So you need to reset. If you're going to use pointers, you want to reset the pointer to the beginning. So this is extremely important now. Otherwise, you're going to be pointing at the wrong data. And how do you reset it? AARPTR, again, equals my array. So what you're saying here is you're taking the pointer back to the beginning. That way, we can go ahead and start again from the beginning. So let's go ahead and do another one. Now remember, I'm redeclaring I because I is only local to the loop. Okay? Right? Unless you've declared I in the declaration block here. Okay, so you can, but in C++, you could do it this way. That's not a problem. So let's go ahead and do a 0, I less than size, I plus plus, and we're going to have a single well, actually a couple statements because you need to move the pointer as well. So notice my use of curly braces because I know I'm going to need more than one statement to complete this. So first, cout, and then you could do something like this, element. Now, you could use the I to show this is element 0. And then equals. Now, what you need to do is dereference the pointer. So you can actually look at the content of the pointer. So what would that be? Star AARPTR. Okay? And then L. That will give me a new line. Now remember that you need to move the pointer. Otherwise, you're going to be reading the first element over and over. So AARPTR, notice you don't use a star if you're moving the actual pointer. If you're dereferencing, which means you're interested in the data pointed to by the pointer, then you use the star. Okay? Fantastic. Now let's see how this works. Let's compile and run. Enter a number, 11.2. Enter another number, 0.34. Enter another number, minus 1.2. Enter another number, 100. Enter another number, 0. And there you have it. Element 0 has that, element 1, etc., etc., etc. In the next video, we're going to learn and we're going to expand on why we would want to use pointers. And they're going to come in handy if you want the arrays to be populated in another function other than main.